Good afternoon, fellow Foundrymen. On behalf of Chennai chapter, I welcome all the fellow Foundrymen for this wonderful session. Today, the technical webinar is going to be on energy conservation. Dr. Sivakumar, the energy consultant from Coimbatore, who is also a BE certified energy auditor, is going to talk about opportunities on energy conservation and energy efficiency measures in foundries, which is a very needed topic for all the foundries in the present scenario. The energy cost, everybody know that the energy cost is going up, and the P&L is getting affected directly. So his input on this topic definitely will give benefit to all the fellow foundrymen. I request all the members, participants to mute your mobile so that the session will be very clear to all. Any questions can be raised at the end of the program to Dr. Sivakumar, and Doctor will be in a position to give full clarification to all the members. So now I request our Chennai chapter council member, Mr. Neva Prasad, to introduce Dr. Sivakumar to all the participants. Now over to Neva Prasad. Thank you.
Thank you, Raman sir.
Yeah.
It's my pleasure to introduce today's speaker, Dr. R. Sivakumar. R. Sivakumar is a certified energy auditor by Bureau of Energy Efficiency. He was worked as a cluster leader at Coimbatore for GEF UNIDO BEE project on promoting energy efficiency and renewable energy collected MSME clusters in India from July to December 2022. Presently, he engaged as cluster coordinator for UNDP Deolite project on low carbon technology deployment in secondary steel units in Coimbatore and Palakkad cluster. He has 25 years of field experience in plant maintenance, projects, energy conservation, energy efficiency training and commissioning, etc. He writes energy conservation and energy efficiency articles in many international and national conferences and workshops. He educates and trains the engineering college students and faculties in the field of management and energy conservation. He serves various positions in the industries: DuPont India Private Limited, Precall Limited, MMG India Private Limited, and Coimbatore Institute of Engineering and Technology. He submitted 70 detailed project reports, energy efficiency projects implemented through the project. He served around 30 lakhs kilowatts hours saved per annum. Nearly 1,200 members in cluster. 60 industries: textile, paper, tea, food, engineering industries. Group of institutions. The Society of Energy Engineers and Managers, and is a member of ISTE. Thank you, sir. It's over to you, sir. Thank you. Sivakumar, sir.
Yeah, yes, sir.
Over to you, sir.
Yeah, very good afternoon to everyone. First of all, I thank Institute of Indian Foundrymen Chennai chapter for preferring me to deliver the session on opportunities on energy conservation and energy efficiency measure in foundries. First of all, I thank Mr. V.K. Raman, Chairman, and Vignesh Ramanan, Vice Chairman, and P. Sendil Kumar, Honorary Secretary, and Raj Mohan Sir as a Joint Secretary, and Mr. R.S. Kumar, Honorary Treasurer. And also, I welcome all the fellow foundrymen. In spite of your busy schedule, you are attending the webinar, this session through webinar mode. So first of all, I thank IAF Chennai chapter also and the Southern Region chapter also for giving this opportunity to deliver this session, sir. So basically, I'm the certified energy auditor. Earlier, I worked with the GEF UNIDO BE project on promoting energy efficiency in selected MSME. as a foundry cluster for Coimbatore for last 9 years, from 2014 July to up to December 2022. So we are engaged and visited more number of foundries in Coimbatore. Almost some 70 to 80 energy audits are conducted in the foundry area in Coimbatore, and we have saved a lot of energy and the technologies are implemented. So basically, these foundries are very energy consumption, highly consumed industries. So we have a lot of scopes for improvement. Even though without investment also we can do some wonders by adapting the best operating practices in the foundry for saving the energy as well as the conserve the energy. So the today agenda is first thing, why do we do energy conservation and what is the benefit of energy conservation? Then best operating practices in melting along with some case studies implemented in Coimbatore, and what are the best operating practices in motors and best operating practices in pumps and blowers. Because next month also there is another session is there. In that session we can cover air compressors and what is the importance of energy audit. Sir, I'm audible, sir, so far? Hello?
Yes, sir, audible, sir.
Yes,
audible, sir.
Okay, sir. So first thing is first chapter is energy conservation. Why do we need energy conservation, sir? Because in India, almost some 60% of the energy, that means the power generated through the fossil fuel based generation only, thermal plant only. What is the fossil fuel? Basically, fossil fuels and all comes under coal, oil and LPG. These are the major things of fossil fuels, because fossil fuels are depleted with time. So today, as on date, our central electricity authority, you can go through the Ministry of Power or CE website. There are a regular update was happen for every 2 to 3 months. What is the current installed power capacity in India as on date? So as on 31st May 2023. Our installed capacity is around 4,17,668 megawatt is the installed power capacity. If you are compared some 20 years before, you compare the installed capacity in the year 2002, only 1,47,000 megawatt only. But within this 21 years span, the energy sector is growing into 3 times.
Sir, excuse me, the slides are not changing, sir.
Yes, sir. Yes, sir. The slides are coming, sir. Just
Sivakumar, sir,
so,
slides are not
yes,
changing.
sir. Yeah, no, not moving the slide. Just to explain what is the need of energy conservation. So from 1,47,000 megawatt to now we are under 4,17,000 megawatt. Okay. So for any country, the development like gross domestic product, because it is a good indicator of any country development. So if the GDP rate is increasing, means parallelly the power sector is also increasing. Okay. So that we are having less amount of natural resources like coal, oil and gases. Almost 90% of the resources are not available in India as per our consumption. We are depending on the other countries only, so that our energy conscious should be very more, because these are all depleted day by day. So coal consumption is coming for next 120 years only. So 20 years before the statistics says 200 years. Okay. So these are all the various reasons for conserving the energy.
Members, please mute your system or phones. Very noisy. Please, members, please support us.
Okay, sir. Can I continue?
Yes, sir. Please.
Yeah. So these are the main reasons. Now everyone was very much interested in saving the energy as well as energy, because the energy cost is almost second to the raw material and the manpower. The third element is for any manufacturing industries like foundry, textile, or any manufacturing process. Energy cost is a major element. So, and also especially in Tamil Nadu, last year they changed the tariff structure. So almost 27% the price hike was happened. So energy saving is not only saving the cost saving is also happening within the industry. So the productivity is competitiveness is increasing, your profit is also increasing. Mainly the greenhouse gas emissions due to this energy consumption that has to be reduced. This is the main intention, so that government is also working parallelly to all the industries to promoting the energy efficiency and the renewable energy. So recently Modi is also committed by 2030, whatever the energy generation, it should be came by 50% of the energy generation is came from renewable. That means forecasting is 8 lakh megawatt in 2030. So now it is 4 lakh 17,000 megawatt. You imagine 4 lakh 17,000 to 8 lakh megawatt by 2030. By the year 2030, we are promising to the world and under this COP, that is a conference of parties. So in 2030, the total generation from the power generation through 50% by the renewable, and by 2070, 100% renewable, that is net carbon zero emission, that is a zero carbon net zero carbon emission was committed by India. These are the energy outlook of the India's government scenario. So every industry should be concerned on energy. So first thing is, what is the importance of energy conservation? See, in this graph, you see there is a bell curve is there. So after this 1995, the more industrial activities happen in India, so they keep on rising.
We are unable to see the curve, sir. Please make it PowerPoint presentation. Yeah, full slide.
Yeah, this second slide is moved, no? Importance of energy conservation.
No, I don't see, only first slide I'm seeing.
So slides are not moving, sir. Only first slide is there.
Slides not getting changed.
Yeah.
Now it is moving?
No.
No, sir.
Sir, please unshare and share. Yeah, that will be there.
Sir, it is visible? Hello?
Yes, sir. Yeah. Okay, no.
Okay.
Yes. Okay.
Okay. Okay. So in this curve, the bell curve says almost 60% of the resources we are consumed so far. So 75% of the energy can be taken from the non-renewable sources only. So this is a very big alarming. So by after 21st century, the natural the resources of fossil fuels is very, very big question mark in the throughout the world. So that's why we need to conserve the energy. So basically, the energy is classified into two types. One is renewable, and the second one is non-renewable. Renewable means it is came from the natural resources like solar, wind, hydroelectricity, and the biomass. Whereas other than this energy renewable, they are coming under this non-renewable, mainly fossil fuels, coal, oil, and gases. See, this is the one alarming statement. Every drop of loss in a particular plant, every second, it can cost over 2,000 liters per year. So every small leakages in the diesel or any oil leakages within the plant, it should be immediately arrested. So every drop of oil per second, it leads to 2,000 liters of oil is wasted. So this is a sector-wise energy consumption. In India, almost 49 to 50% of the total energy consumed by industry, and the transport sector is 22%, residential is 10%, agriculture is 5%, and others is 14%. So the industry sector is the major thing. Almost 50% of the energy is consumed by industry, and the remaining some 25% alone for transport sector. So recently, that in the transport sector, some revolutions have happened. Everyone knows the e-vehicle is predominantly it is familiar, and it is also growing. So in the next couple of 5 years, maybe in the after 5 years, maybe in the 28 or 30, majority of the vehicle in the road will be e-vehicle. So that for e-vehicle also we need some energy to charging the battery. So again, there is a question mark is there. So the e-transport is also increasing. So this is the point earlier I told, the fossil fuel reserves in globally, the coal available in the global level is only 861 billion tons. That is the reserve to production ratio is 120 years at the present consumption rate. What is meant by reserve to production rate means every financial year they declared what is the present energy generation and how much coal they are used. The same, if the same rate of coal is consuming for the coming year, then the coal availability is only 120 years. This is the indicator. This is the thing earlier I told in the first slide. So somewhere in the 2002, the statistics says the coal availability is somewhere some 1,150 billion tons, and the reserve to production ratio is 200 years. But within 20 years, what happened? The coal reserve is also reduced from 1145 billion tons to 861 billion tons, and this value is also changed from 200 to 120, because 80 years consumption was consumed by within 20 years, because that much fast rate of power sector was parallelly it was developed not only in India, everywhere, China and all developing countries, they are increasing the power capacity, and also the every Indians, the per capita energy consumption is also increased. So 20 years before, the average per capita energy consumption of India is 650 kilowatt per units per Indian, whereas now it is comes around 1,250 units per Indian. So almost we are also crossing double the energy consumption by 20 years. Still it is increasing. So that for any country, the development and the growth, the energy sector is also parallelly developed. Otherwise, the economy is not developed. Similarly, for coal, no, oil is also available for 1,669 billion barrels only. The available resources only for 42 years only. So after 42 years, how we are running the vehicle, we don't know. So, hello? Hello?
Yes, sir. Over, sir.
Yeah, sir. Yes, sir. So gas reserve is also slightly increasing. 20 years before, this figure is says only 50 years, 50 years only. Now there are some new traces are identified. That's why the reserve production ratio is gradually increasing 60 years. But still, this is also alarming. This is the global energy resources are available. So that in India, it is very, very less. Only we are having coal percentage is less than 12% of the world coal reserve is available in India. Oil is less than 8% only. Gas is also very, very minimum value only. So in India wise, we are purely depending on the other countries, mainly for oil and gas. Middle East we are depending. So that the energy security is also very question mark. Now there is a war is happening. So every war is happening. Earlier Ukraine war is happened. The fuel price is also increasing. Now the Israel-Palestine war was happening. So these are the worldwide political scenario is also changing the energy prices and other things. So what is the effect of using these fossil fuels? By using this coal, oil, and gas, no, it is generating lot of environmental polluted gases like CO2, carbon dioxide is a major greenhouse gas emissions by these fossil fuels, and also it releases some SOx and NOx, that is sulfur oxide and nitrous oxide. It is very, very harmful. So these are all the various greenhouse gas emissions are emitted by utilizing these fossil fuels. But this greenhouse gas emissions, no, these gases are polluting our environment also. So electricity generated from fossil fuels such as coal and crude oil, it lead high concentration of harmful gases in the atmosphere. So this will turn to lead problems such as ozone depletion and global warming. Vehicular pollution is also nowadays very give a much more problem, especially in Delhi area. The atmospheric temperature and pollution is very much higher in major metro cities like Delhi, Chennai, Calcutta, and Mumbai. Nowadays in Coimbatore is also the vehicular density is very, very high compared to some 5 to 10 years before. So these are all the various effect of using these fossil fuels. So as an energy outlook of India, what are the challenges and these are the if we are facing India? Our population is almost 140 crores. That is 1.4 billion out of 8 billion. So 15% of the global population is lying with India. And we have only 0.5% only world petroleum reserve and 10% coal reserve. And we are expecting 8 to 10% GDP. So 8 to 10% GDP means is the same level the energy sector is also going. Otherwise, the economy is not developed. So these are the various challenges are faced by the Indians. Government is also facing the same thing. So the bureaucrats are creating such a way the policies are adapted and how the energy can be saved, how the fuel importing prices, all these things are taken care by this government is also. These are the some of the challenges faced by India as an energy outlook. So these are the, due to this greenhouse gas emissions, no, these are the various potential thing was happen for global warming and the climatic change impact, increasing the ocean temperature and rising the sea levels and the snow and ice melting and the extreme weather events, more severe heat waves and loss of biodiversity, increased diseases, food shortages. These are all the various problems happen due to this greenhouse gas emissions. See this picture, typically this picture came out from one of the power plant, the steam plant, boiler-based power plant. So every unit of electricity, it uses 0.28 kg of, releases 0.82 kg of CO2, carbon dioxide at the power station. And every kg of coal, it produces only 2.2 units only. So averagely for unit of electricity generation, it needs 0.478 kg of coal. Basically, our thermal based power plant, no, the efficiency rate is very, very less. Only 30 to 35% of the efficiency is the maximum efficiency of our Indian boiler, steam generated boiler plant. There is a power station boiler plant. So every kg of coal, it should be generated around 4.5 to 5 units of electricity. But practically, they generated only produced 2.2 because of there are various losses associated in the power generation itself. Again, this generated power will be transmitted from one point to another point, state grid and the national grid level. It is transferred to via high voltages, extra high voltages, EHT. So even though for the transmission in the HT line, no, there are transmission and distribution losses are there. So there is a mantra told, as a consumer, we save 1 unit of energy, unit of electricity means we are saving 2 units, we are avoiding 2 units of generation in the power plant. So that's why even we are saving some 10 units per day in a plant. That means we are avoiding 20 units generation in the power plant. Nowadays, the power plant installation cost is also very, very high. So all these things are considered only. That's why the government was promoted this energy conservation and energy efficiency activities in all the industries. That's why the Ministry of Power was created one agency called Bureau of Energy Efficiency. So every year, December 14th, they celebrated as a National Energy Conservation Day. So during that time, they are awarded the various industry for achieving the energy efficiency and the best practices in the country for the various sectors. So these power plants are burns 1.85 to 1.87 billion tons of coal every day to produce the electricity. So we are using a lot of fuels used in the industry. Mainly, we are depending on the most of the industries are electricity. If we are consuming 1 unit of electricity, means it is equivalent to kilocalorific value is 860. For coal and coke, it is almost 4,200 to 6,500 kilocalories. It is depends on the coal natural availability taken from the African coal or Indonesian coal or Indian coal. Normally, the Indonesian coal kilocalorific value is somewhere 5,500 to 6,000 kilocalories. So this value should be given by the supplier. Whoever purchasing this coal, diesel, and furnace oil, gas, no, you have to get it the information specific calorific value from the supplier. So for the diesel, the calorific value is 9783, furnace oil is 9383, gas is 12,500. So in northern states, many areas, the Adani pipeline, gas pipelines are available. They are using more CBM, coal bed methane. So easily the industry can tap the CBM gases. It is similar to natural gases they are using for the applications. But in Tamil Nadu, this case is very, very less. But from Cochin to Bangalore, the pipeline is laying. So few industries in the Palakkad and the Kanjikode area, they are very get soon with the natural gas line from the steel production industries also. So this is the Indian energy scenario. So as on date 31st 5th 2023, the installed capacity is 4,17,688 megawatt. So out of this, the fossil fuel is 56.8, roughly 60%, and non-fossil fuels means renewable and nuclear come together 41.6. This percentage will be earlier I told, no, by 2030 the generation from the fossil fuel to be 50 and the renewable and the non-fossil by 50%. By 2070, this fossil fuel will be 0 and the non-fossil will be 100. So this is our total generation in the India, the power sector, how the generation is there. In the year 2029 to 10, the generation capacity is 805.4 billion units are generated. Slowly it is increasing. Now in 2022-23, the financial year, 1,624.2 billion units are generated. From the graph itself, we can see the power sector, how they are growing gradually. Okay, this is the indicator of the country GDP versus the power sector development. The growth generation is also 7.15, 5.59, 9.14. Now in 2022-23 is also 8.87. Again, 23-24 is also expecting somewhere 9 to 8%. Similarly, the power sector is keep on gradually it is growing on. Why this value is negative? Because 2022 and 1920s the COVID lockdown has happened, so that's why the generation and growth is not happened much. But again, it was picked up. The indices are picked up. So every year we received some data from the Tamil Nadu electricity consumer. Now I thank to Tika for producing this kind of information on every day. So this data privileged the 1st November 2023. The availability is 336.93 million units capacity from the Tamil Nadu Generation Distribution Corporation, that is a TNEB. So demand is 335.66. So we are getting 84.91 million units from the thermal power plant, 6.51 from the hydro, that is a dam-based hydro plant, and the gas and naphtha is 3.48, wind is 6.95, solar and the bio, and the central grid is also we are getting around 190.8 million units every day. So this is the daily statistics data we received. Here, there is a thing is in wind only 6.95 because the wind season is over. Normally, the wind season is May 15th to October 15th only. This 5 months period only the generation will be very high. Other the 7 months the generation is very low. That's why this value is very low. Otherwise, mostly in Tamil Nadu, the wind energy was give a good backup during this 5 months period from May 15th to up to October 15th. So the generation is very, very high during this period. So this is the power development in India. You see the fact in 1997, 1947, at the time of independence, the installed capacity is only 1,362 megawatt. Now it is up to 1,17,668. It is keep on increasing. So this is the sector improvement. See why I am indicating like this one, no, 1,362 in the year 2002. The generation capacity is only 1,05,046 megawatt. Again, 2020 we are increasing to 3,70,000, and within 3 years period again there is almost some 45 to 48,000 megawatt is increasing within 5 years period. This is the various development stages in the power development. So far we are seeing the power scenario in India. So now we come to the subject, the energy conservation and the energy efficiency. What is meant by energy management? It is the process of monitoring, controlling, and conserving the energy in a building, factory, or organization. So energy conservation and the energy efficiency. What is the minor difference between these two? Because during energy conservation also we are saving some energy. By improving the energy efficiency also we are saving some energy. What is the main difference means? This example, for example, you have a conference in your room. So there are some 10 lights are there. So out of 10 lights, you can managing the conference with the help of 4 lights, so that you are forcefully switch off the 6 lights. So by reducing the 6 lights, no, you are saving some energy. But whereas your comfort level is somewhere you are compromising. So in that case, you are adapting, the old lamps can be replaced with the energy efficient LED bulb. No, nowadays LED bulb is only 50 to 60% energy saving can be done from the existing old bulbs. So without compromising, the old lamps can be replaced with the energy efficient lamps. Then you are achieving energy efficiency. Here also you are achieving some energy saving. But here in energy efficiency practices, you are not this one. You are not your comfort level is not disturbed. Where in the energy conservation, we are somewhere we are our sacrifice our comfort level and do these things. So this is a classical example. The similar way only every day the industrial practices to be done. Hello, I am audible, sir. So far the presentation is okay. Hello.
Yes, sir. Going good. Very good, sir. Proceed.
Okay, sir. Okay. So this is the one example. So earlier days we are using the incandescent bulb for 60 watts. If we are consuming this 60 watts per hour, it takes 60 watts of energy. So it releases the carbon dioxide emission is almost 65 grams per hour. For example, this lamp is running for 5 hours per day, means it generating 65 into 5. That much CO2 emissions grams will be released by replacing this old lamp with energy efficient CFL lamp. Now the CFL is also superseded. Now we are going for LED lamps. So from incandescent bulb to CFL, see the energy consumption rate here 60 watts, it's consuming only 15 watts. Only 75% of the energy can be saved with the latest technology. Now this LEDs is also offer some 8 to 10 watts only, still more efficient compared to CFL. And CO2 emission is also see here 65 grams per hour. Now it is 16 gram. By using LED means it is consuming only 8. It releases 8 to 10 grams per hour only. So the energy efficiency equipments uses less energy for same output, and it reduces the CO2 emission. This is the main thing. So energy efficiency means it uses less energy, and also it emits greenhouse gas emissions. CO2 emissions is also very less. So what are the various benefits as an industry, as a nation, as a globe? So if best practices and energy efficiency, energy conservation measures adapted by industry in every year some 3 to 4% of the total energy consumption is reduced by the industry, means defaultly the reducing the energy bills, overall energy bills is reduced. Due to this, the competitiveness is increasing, and the productivity is also increasing, and the quality of the product is also increased, and they are playing with the other players. So the net profit is also increasing for the industry. So the overall benefit is, these are the few words only. But for what is the benefit of nation? The reducing the energy imports. Already we are depending 95% of the energy was depending on the neighbor countries only. Other countries only we are imported. So the energy security is also very important thing, and avoided cost can be used for poverty reduction. So every megawatt power plant installation, there are a lot of crores to be spent. So if we are conscious with the energy saving and the energy conservation activity, then this power plant avoided cost can be used for the other schemes called poverty reduction and the conservation of limited resources and improve the energy security. These are the various benefits with nation. And what is the global level benefit? We are reducing the greenhouse gas emissions and other emissions, and also maintainable environment under sustainability in the global level. These are the various energy benefits between industry, nation, and the globe. Okay, so far we are seeing what is the need of energy conservation. Now we come to our major area in foundry. What is the best operating practices in melting? So far it is clear, no? If any doubts, sir? Because
No,
the questions will be raised in the last. No?
Okay, yeah, last we will have. Yes,
no doubt, sir.
Okay, this is the energy consumption pattern in a foundry. It is taken for only induction furnace based foundry. Typically, any induction furnace based foundry unit, the majority of the energy is spent in the melting section, almost 70%. But as an individual foundry to foundry, it is varied from 65 to 75%. Some units are using 80% also. So other area is also mold preparation is 10%, sand preparation is 6%, compressor is 5%, lighting is 5%, and maybe lighting is also small, maybe 2 to 3% only, because of adoption of energy efficient LED lamps and induction lamps. Most of the industries are adopted, so this percentage will be reducing, and others is miscellaneous is 4%. So our main aim is to reduce the melting area. Melting is consuming more energy. Even though we are reducing some 1% or 1.5%, it will give more impact in your energy bill value. So energy consumption in melting, any modern foundry, they are using induction furnaces only. So it is working under the principle of eddy current principle, induction principle. Normally the coil is carrying the high frequency current up to 500 hertz to 2000 hertz. So the alternating magnetic field produces the high frequency, and the current induces powerful eddy currents to the charging material so that it was heating. So it is the principle behind the induction furnace. Basically, it is similar to transformer only. In the transformer, there is one primary, there is one secondary. Here, the induction furnace, The secondary is whatever the charged material we are loaded into the crucible, it is acting as a secondary. So the primary side, we are given some voltage, so it is converted from the AC to DC, DC to AC. Again, it is inverting, so high frequency current will be carried over. So because of this eddy current principle, the melting must happen. So normally the thumb rule says, as a thing is for 1500 degree, 1 tonnage of iron metal to be melted from solid to liquid at the rate of 1500, the theoretical energy requirement is somewhere 393 to 394 units only. But practically we end up with more than 600 to 700 range. For any foundry, the range of specific energy consumption per ton is varied from 600 to 800 units per ton. Okay, because of the various operating practices and difficulty. Later on we see. Okay, so the best operating practices for induction furnaces, operation efficiency of induction furnaces involves preparation with the right mix of raw material, charging of stock, melting, and pouring of mold. So some few best operating practices we discussed in this chapter in melting. First one is furnace lining preparation. The furnace lining plays an important role in overall performance of an induction furnace. So linings to be done as per the furnace manufacturer recommendation to get the optimum result for energy out consumption as well as the liquid metal output. The selection of appropriate lining material, thickness, and sintering plays an important role in the energy savings. So the lining is very, very important. So thick lining reduces the crucible volume and hence the molten metal output, resulting it leads to high energy consumption. And the thin lining is also thin lining, though it improves the power density, promotes heat loss from the sidewalls. Lining material with high thermal conductivity causes more heat loss. So improper lining causes a premature failure. So the furnace lining is very, very important because do not increasing the lining thickness at the bottom or side walls. Okay, because every foundrymen are following these practices. We are well known. So increasing the lining means it reducing the capacity of the furnace and it leads in increasing the energy consumption. That means power consumption is increasing. So normally during the lining completed, in the initial first 50 heats, the capacity is 1 ton capacity. The furnace power capacity is 750 kilowatt, means maybe you are taken within 50 to 15 minutes, you take one tap every tap. So after 50th heat or 51st heat, you are facing some problem because of more slag is accumulating inside and the lining is also slightly affected, so that your capacity is also reduced. So the melt timing is also increased. Due to this, the overall energy consumption is also increasing. Okay, so the effect of increasing or decreasing the lining thickness, it is related with the power consumption rate also. So do not allow the furnace to cool very slow. Okay, forced cooling air helps also cracking the lower depth. So this one is normally the lining is a very, very important thing for any for induction furnaces. It may play a major role with respect to the furnace throughput, that is output liquid metal versus specific energy consumption. And preparation of raw material. So the energy consumption pattern of the induction furnace is also purely depends on the quality of scrap into feed into the furnace area. So weighing and arrange the raw material on the melt floor nearer to the furnace before starting the melting. I think most of the foundry units are doing this best practices in the top area. So next campaign metal to be weighed and separately kept in the furnace for the next batch. And the charge must be free from sand and dirt and oil grease. So this rusty scrap, it takes it leads to more slag formation and it contains less metal per charging. So it leads more slag formation inside the crucible. If more slag is there, so slag is increasing means the power consumption is also increasing. It reduces the metal output is also. The foundry return must be, that means the runner and the riser must be short blasted to remove the sand before pouring into the furnace. Mostly some 50% of the foundries are following these practices. Few foundries are not following. So before putting the runnerizer, with the sand, the runnerizers should be short blasted, then they have to put it into the furnace. So it consists of almost 2 to 5% of the sand by weight. Once the sand was going inside the crucible, it is converted as a slag only. So wherever the slag is increasing, it reduces the lining life also, and also your energy consumption is also increasing. Keep exact weight of alloys ready before charging, as the alloys are very expensive. This practice is to be followed, and proper handling will not reduce wastage but also reduce the time lost in alloying. The maximum size of single piece of metal scrap should not be more than 1/3 of the diameter of the furnace crucible. So all the OEMs are specifically told to the foundrymen during the installation. So whatever the crucible size, the metal pieces to be scrap sizes to be less than 1/3 of the diameter, so that such a way the scrap to be broken and put it in the crucible. And there should be a sharp edges practically in the case of heavy and bulky scrap. So this may damage the refractory. So this care to be done before pouring the metal into the crucible. Any sharp edges means you have to carefully charge the metal into the crucible. So scrap charging, subsequent to the preparation of raw material, the next step is the scrap into the furnace. The melting efficiency of the induction furnace is predominantly based on the charging process also. So size of the charge is an important parameter to reduce the consumption, because the scrap charge should be as dense as possible, so that the less air pocket between the scrap pieces to be maintained, so that you are having more power density and higher the heat conductivity. It leads more faster rate of the melt rating, and ultimately the energy consumption is also reduced. Use as much as possible small pieces of scrap as possible to get the optimum result. So these are the some practices to be adapted in the shop floor itself and the melting area itself. Scrap should be charged continuously as the melting proceeds as continuous charges. Avoid charging a furnace beyond the coil level, that is the charging the furnace to its capacity. But mostly it was not happened. Above the charge coil level only the metals are charged, and the proper charge sequence must be followed. Bigger size metal should be charged first, then followed by the smaller size, and the gaps to be filled, so that such a way the borings and the turnings and small material to be tight packed inside the crucible. So it leads more eddy current was thrown and the melt rate is increasing. So melt rating is faster means your energy consumption is reduced and the melt timing is reduced. So power input, the power input provided for running an induction furnace during the melting operation is also very important. Few industries during our audit we are facing, due to this maximum demand, sanctioned demand is lesser than the is not optimized. That is the reason the 750 kilowatt may be operated at the rate of 600 kilowatt. So that definitely the melt timing is increasing. Due to that, the energy consumption is also increasing. So such a way, what is our maximum demand availability? What is the demand used for the auxiliary load? So the maximum power can be utilized in the furnace area. So to minimize the melt timing as well as the energy consumption is also reduced. I saw one case study in later part. So the run the furnace at maximum power since beginning. So the maximum power input increases the rate of melting and hence reduces the cycle time of the heat. So the power factor to be maintained nearer to 1. So practically this should be 0.98 and above to be maintained, and ensure no voltage drop from the source by turnings and borings. Deslagging and sampling. Formation of slag in the furnace should be avoided, and it leads to increase in energy consumption. So every slag was adding some additional energy. So carry out the deslagging once the furnace is full with the molten metal and has attained the temperature of 1400 degree. Avoid slag deposition and mining by complete removal of slag. So after deslagging, samples should be taken and sent to chemical laboratory. And the sampling, mostly the industry's practices is the spectro testing, and the result arrival takes around 7 to 10 minutes. This has to be minimized. So the spectro lab should be very closer to the induction furnace area, so that once the sample is going and the tester, the result should be given to the melt sub supervisor within 2 to 3 minutes. As much as possible, it is reduced. Your melt timing is also reduced. Your energy consumption is also reduced. What are the other practices to avoid unnecessary superheating of bath, maximize the equipment utilization, maintaining the buffer stock, that is a raw material stock to be available as much as possible, and the proper production to be scheduled based on that schedule only, the furnaces to be run. Otherwise, every day they are running for 12 hours. Then the 12 hours the furnace is off means every day cold start is also leads more energy. So these are should be avoided, and the preventive maintenance to be carried out at regular interval, and streamline the temperature measurement and sampling. Already discussed. So the distance between the spectro testing and the soft floor to be very minimum, so that whenever the sampling is going for the spectro measurement, the results should be published immediately within 2 to 3 minutes, so that the timing will be reduced. So these are the various best operating practices to be followed in the melting area. Apart from this, the effective of raw material storage is also very important for optimum performance. So this bundled scrap is also stored on the floor area. So it should be followed. And the coil cooling and the panel cooling, water temperature and the flow rate to be monitored every hour basis. Also, at least in a shift 2 times the values to be noted. The panel must be checked on weekly basis, and the cleaning must be done on monthly basis. Check the conditions of the cooling tower also. These are the additional things to be followed in the auxiliary area. Otherwise, if anything is failed in the auxiliary area, it leads the furnaces ideal, so that your breakdown time because of any pump failure or cooling tower issue, your furnace should be ideal, and furnace is also forced to stop. So all the auxiliary equipment is associated with the furnace is also keep ready, and all the maintenance to be activities to be done. So best operating practices in melting. So do's and do nots. Keep the size of charge material to about 1/3 of the furnace crucible, and do not superheat the metal. This is do not. Operate the furnace at full power and full capacity. Go for maximum compaction of material while charging, and do not hold the material in the furnace. It consumes power without increasing the production, and keep the cycle time as short as possible by proper housekeeping. And do not uncover the furnace unnecessarily. Maximum the cover lid to be provided as much as possible. And maintaining the minimum holding period for melt. Separate holding furnaces can sometimes be useful. Avoid long tapping time and the frequency to reduce radiation losses and to reduce operation at low power loss. During my energy study and during the visits to the most of the foundry, this is the major thing. So the metal is made ready, but they are not able to tap it into the box because the box is not ready. So if the box is not ready means even though the metal is ready, they are not able to pour the metal into the boxes. It takes additional 5 to 10 minutes means unnecessarily the metal to be heated with some 50 to 100 kilowatt to be maintained in the furnace. So these are the waste of energy, as well as the timing is also, melt timing is also increased. So the proper planning to be made in the shop floor. By once the metal is ready means that has to be immediately tapped and the pouring to be started, and within 2 to 3 minutes the pouring is completed. The maximum time is 5 minutes. So after 5th minute the next campaign to be started. And wherever it is possible, preheating the ladle for energy saving. So nowadays, most of the steel foundries are adapting this LPG fired or oil fired ladle preheating is there, so that we can save some energy due to this ladle preheating, and avoid long charging time and the frequency. This is the do nots. So already we discussed. So the thermal, the main function of the induction furnaces is, there is a principle is the induction principle only. Based on the eddy current law, it is converted from the secondary is generating more current, it acting as a secondary. So the induction principle is there. So the thermal efficiency of the induction furnace generally ranges from 60 to 75% only. Nowadays, it can be increased to 80 to 85% also. So what are the losses associated with the furnace? Electrical losses, AC to DC, DC to AC converter loss, because we are given the power in the incoming AC. Again, this AC will be converted into DC. Again, this DC is converted into AC at the rate of mid-range frequency, 500 to 2000 Hz. And there are various losses in the copper bus bar and water-cooled lead losses. And the induction coil losses is there. There is I square R losses, conduction losses, and the radiation losses. These are the various losses. So ideally, they speak 394 units per ton of liquid metal to be taken at the rate of 1500 degree. Again, another some 100 to 130 units will be losses due to this various losses from 1 to 5. So it leads the overall energy consumption is above 600 units is the practical. So this is the factors affecting the extra power. See, every returns with the 25 kg ton with the sand means it rises 12 units per ton. And the rusty charge material is also leading 27 units per ton. Melting with the half power is also leading extra 18 units per ton. And heel metal melting is also leads 36 units per ton. And the excessive fume extraction is also leads 14 kW per ton, kilowatt per ton. So this is the various thermal losses, conductive losses through the lining, heat losses associated with the slag, and the radiation losses through the openings are the various thermal losses. And parameters to be measured: weight, the total metallic charge per ton, number of batches melted, and the power consumption. Based on that, you can arrive the specific energy consumption of the individual melt campaign to be recorded in the day ways. And mostly in all the foundry, they are having the logbook sheet is there. So in all the process to be entered. So each and every heat they are taken the specific energy consumption is also. So how to arrive the furnace efficiency? This is the formula. So efficiency is basically it's output by input. So here the efficiency is depends on the theoretically heat required for melting divided by actual electricity consumed for melting. So the theoretical heating is into two parts. One is H1 and H2. That is for heating the metal and heating the slag. Energy required for that is heat required for heating the metal and heat required for heating the slag. H1 and H2. So H1 is major thing. Wm into Cp into delta T plus H is the latent heat divided by 3600 joules. That is kilojoules means this 3600 kilojoules is equal to 1 unit. So that's why it gives a kilowatt hour. That is a theoretical heat required. And the slag material is also 1.65 into Ws by 3.6. You see the one example. So melting of scrap for 1 ton. The quality of metal is 1 ton. The slag quantity is 25 kg. So the specific heat of the metal is 0.682 kilojoules per kg. The latent heat of the metal is 272. Latent heat is nothing but from solid to liquid stage. How much thermal energy needed? That is called latent heat. The melting temperature is 1650 degree. The charge temperature is 30 degree. So put all the parameters as per the previous formula. No? In this formula, the theoretical heat required for this achieving is 382.45 units only. For heating the slag also, it needs 11.45 units. So both H1 and H2, it needs only 394 units only. Whereas practically the electricity consumed by the mains is 625 units. So that theoretical requirement is 394. Practically they achieved 625 units per ton. So the efficiency is 394 by 625. It gives 63% is the furnace efficiency. So far it's okay, sir. I'm audible.
Yes,
Hello?
sir. Yes, sir. Yeah, it is clear now.
Okay.
Yes, sir, we are audible.
Okay, sir. Here I shared some of the case studies in melting. See, in one of the foundry, we adopted the best operating practices in both the sintering and the raw material charging pattern. So it leads to reduce the specific energy consumption for the liquid metal up to 8%, increasing the melting efficiency, and melt timing is also reduced up to 8 to 10 minutes. Energy savings per heat is around 30 units. So what all the thing is happening in the sintering practices, we follow these practices. Earlier practices, they used to have 0 to 60 minutes, the GLD current was noted. So 0 kilowatt for 60 minutes, GLD current noted as it is. The second point is 50 kilowatt is given for 60 minutes. Here we give 1 minute 25 kilowatt, 9 minute 0 watt, the 0 kilowatt. So that means in repeated for procedure for every 60 minutes. That means every 10 minutes, one cycle is there. For 1 minute, the 25 kilowatt is given, 9 minutes power is off. So repeatedly, it is done for 60 minutes, that is 6 cycles. Next one is 50 kilowatt and 8 minutes. Gradually, the power is increasing and timing, off timing is reduced. So such a way, we are doing the sintering practices. Finally, we take the full power and take the alloy addition and the metal was scrapped. and this is the raw material charging pattern formed. The same raw material only we change the pattern into the loading into the furnace. So existing practice, pig iron 250 kgs is charged at full power, that is at 350 kilowatt. The proposed method is initially boring was 50 kgs was poured in the lining bottom, and again 100 kgs of pig iron was added. Next 50 kgs of borings are added, and again 50 kgs of pig iron is added in a sequential manner. First boring, second pig iron, third boring, fourth pig iron, such a way. After charge all the 250 kgs of material, then set the maximum power to 350 kilowatt. Here the 250 kgs of pig iron is added. No, next boring was added. Here borings is sequentially added in a slower manner. Borings 50 kg, pig iron 50 kg, again boring. So that in this method, the existing energy consumption is 472.5 kWh per melting campaign. Here we are achieving only 441.2 at the rate of 550 to 580 kgs of per liquid metal. This 472 and 441, the metal output is almost 550 plus 550 kgs was taken, because the crucible capacity is 500 kg and the furnace power capacity is 350 kilowatt. It's a medium small industry, foundry industry. So next, in another industry, the best operating practices in the raw material charging alone. So the existing raw material charging is pig iron 50 kg, CI boring 600 kg, foundry returns is 300 kg, and LMS scrap is 500 kg. So it is a 1 ton furnace, 750 kilowatt is the power range. Here the proposed raw material charging is pig iron is increasing from 50 to 200, CI borings is also 500 kg, foundry returns 300 kg, LMS scrap is nil. So here the saving is, you see the first graph now, it varies from 621 to 643. By changing the practices, the best practices, it gives only 610 units is a maximum average unit. So averagely, because of this charging pattern change, nearly some 20 units can be saved in a ton. Third one is power setting. See, this particular industry, they are having 750 kilowatt furnace with the 1 ton capacity, crucible capacity. Due to this maximum demand availability, they are reducing the power to 600 kilowatt. They are not going above 600 kilowatt due to this demand issues with the EB. So during this audit, we done some auxiliary line also, so that we are forced to inform the foundryman, better you go with up to 50 kilowatt you can give to the furnace, safer side you give 30 kilowatt. So finally from 600 kilowatt to 630 kilowatt is increasing the power setting. So the average setting is value is the previous one is 626 units. Now increasing the 30 kilowatt now from 600 to 630 kilowatt, the energy consumption, average consumption is 617 units only. So the melt timing is also reduced up to 5 minutes. So increased metal output per day 750 kgs, and specific energy consumption is also reduced up to 9 units per ton. So without investment, it was done. So it is a low cost, it is the best operating practices was can be immediately adapted. Only thing, the unit was hesitating to increasing the power because of the demand availability with the EB. So we suggested you go with up to 50 kilowatt. Safer side, the unit was setting as a 630 kilowatt, so that 9 units was saved. So another best practices in melting. Similar things are again the same best operating practices in melting area. The dual track is used as a sharing mode, 1000 kilowatt and 250 kilowatt. Now it is running as a mono track. Full power is given as a 1250 kilowatt is given in a single thing. So earlier the melt timing is 60 minutes. Now it is 50 minutes only. So 55 minutes only. 5 minutes is saved, and always the bottom thickness is maintained by 180 mm. Here they maintain 150 mm. 3 shifts is running. So the specific energy consumption is reduced from 730 to 700 units. So here the material charging is also followed such a way. Solid material is charged first. The second MS scrap is added. Carbon addition is the third, and the CI boring addition is happen. Adding of scrap material 40 to 50 kgs at regular interval, and CI boring is also added. And main thing is the poking to be done at regular interval and the slag to be removed. So such a way the operator to be poke the furnace at the regular interval, they remove the slag. So at the 90% level, the spectrometer testing to be done, and adding the runnerizers. Then based on the spectrometer result and the temperature is reached, then the desired value, the material is capped. So due to this practices, no. So the specific energy consumption is, you see in the January 2021, the 744 units per ton, it is gradually reduced from 744 to 696. So almost somewhere 50 units can be saved. Some 744 to 696 means almost 40 units was saved in a ton. So the raw material charged for 3 heats, this is taken with our power quality analyzer during our energy audit. So we have conducted the trial for 3 continuous heats. This is the metal output and this is the unit consumption. So that the specific energy consumption, even though less, this is the month average. This value is for only the 3 heats only alone, 668.6 units per ton. So these are the some of the practices is taken from the TERI, because the TERI was worked with our cluster, Delhi-based company in our Coimbatore cluster. We are sharing the same thing with your foundrymen also. So by performance optimization of induction press, by using a small pieces of MS scrap by charging, no, they saved nearly 27,503 units can be saved in a year, and 2.1 lakh rupees can be saved, and 27 tons of CO2 emissions was reduced. Similarly, replacing the old furnace with the energy efficient induction furnaces. Nowadays, IGBT models also available. It gives directly some minimum 7 to 8% energy savings from the existing one. So here 1,20,294 units was saved, and 9.1 lakhs was saved cost, and 118 tons of CO2 emission was reduced. So every radiation loss is 25 kilowatt per ton of 500 kg crucible furnace melting at 1040 degree. So lid mechanism can be used, the lid cover to be placed in the furnace, so that it will use 25 units can be saved in a ton. So these are the lid mechanism adapted in the various industries in the northern cluster. It is dynamically prepared by the foundryman himself based on their operator flexibility. So it avoided 23 units per ton. These are all information by the TERI. Okay. This lid mechanism adaptation, no, it reduces the radiation losses from the induction furnace crucible. So it saves 23 units per ton. Similarly, in another one of the foundry, they are adapting this kind of lid mechanism. So they saved 9 units per batch. So far we are covered some best operating practices in induction furnace. So the second major thing is in the utility area, no, a motor. So without motor, there is no industries can run. So what are the best practices and the best energy saving methods can be done in the motor? So this is the general motor. What is the input and what is the output? Normally, motor is a electrical device. It converts the electrical energy into mechanical energy to rotating the application. Whatever the motor, conveyor, or in a foundry means it's a EOT crane is there, and the pump is there. Pump drive the pump motor is required, and also salt blasting machine, fettling area grinder is there. Everywhere the motor is there. So typically the motor efficiency is varied from lot. So in the older area, 20 years before, the IE class efficiency class is not in place. Okay, now every manufacturer to be a manufacturer by using IE standard, that is an international efficiency standard. Earlierly, the class is called as a efficiency class, EFF1, EFF2, EFF3. Okay, here the diagram shows this is the input power, this is the output power. Okay, in any motor, the nameplate says, for example, 10 HP motor, that is a 7.5 kilowatt. What is the meaning of 7.5 kilowatt? The 7.5 kilowatt will be given in the shaft. That is the meaning of rated input power. What is the nameplate of the motor specifies? That means how much energy it takes. 7.5 kilowatt means how much energy it will take based on the efficiency level. For example, your motor is 90% efficiency, 7.5 kilowatt, 10 HP. Then it gives 7.5 kilowatt at the shaft output. It takes energy input is 7.5 divided by 0.9 because 90% is your efficiency. So it comes around 8.6 units can be drawn in the input power. Okay, suppose this efficiency class is increasing from 90 to 95%. What happened? The same 7.5 kilowatt motor at the full load motor, 7.5 divided by 0.95, it will gives around 7.9 to 8 units only. So that 0.5 to 0.6 units can be saved in a single 10 HP motor by changing the energy efficient motor from 90% to 95%. So what are the various losses available? Basically, the motor consists of stator and rotor. Okay, so inside there are iron and core losses is there, stator resistance losses is there, rotor losses is there, windage and friction losses almost 1.5 to 1.8%, and the stray load losses are there. All losses put together, the total losses somewhere 7.6% for the new motor. Okay, so maybe this category is the IE2 or IE3 motor for any make, Siemens or ABB or Crompton Greaves, any make. The IE2 or IE3 standard says 92.4% is the efficiency. Okay. So normally in industry, any industry was doing regular practices of motor rewinding. Okay, what is the importance of motor rewinding? Once the moment the motor is failed, the coil is failed, it was given to the local shop service person. So the local workshop, they remove the stator and the rotor. They are not use the proper cage of wire, so that your again the retrofit of stator and rotor again reassembled. No, that is not up to the factory mark, because in the factory they are using some proper tools for assembling the stator rotor, and the air gaps are maintained, and mainly the wire cages, no, they are maintaining the proper wire cages used for the winding in the stator and rotor. Main thing is for the stator. But whereas in the market availability, they are not using the proper cage, it leads more losses. Once the motor is going for rewinder, the efficiency drop minimum 2%. So if a motor in a lifespan for 10 years or 15 years in a foundry, classical example is EOT crane motors are frequently failure, and the salt blast machine or any grinding machine motor is failed. If the motor is rewinded for more than 5 to 6 times, then the efficiency drop will be more than 15%. So it leads more energy consumption. Better, as per the BE mantra, Bureau of Energy Efficiency also inform all the industries also, do not rewinding the motor more than 3 times. Better, once the 3 time is crossed, better replacing the motor with the energy efficient motor, because in a life cycle time of the any motor, no, the energy consumption is very high. This picture is somewhere 97.3, but practically 95% of the total lifetime cost, no, the energy cost is 95%, and the investment cost is only 3 to 4%, and 2 to 3% for the this one winding, rewinding, or maintenance activities. So in a lifetime cycle cost of any motor and any pump or any equipment, the energy is the major predominant element. So that whenever we purchase a new system or motor, kindly consider for the energy efficient motor. For example, if a machine is running for 20 hours in a day, better you consider for a higher efficient motor, IE3 or IE4 instead of IE1. Suppose the motor is running for 1 hour or 2 hours in a day, you may go with IE1. But better for long running motor and higher consumption motor, consider this higher efficiency motor. Now the cross-function teams are formed in many industries, so that the maintenance team and the purchase team to be collaboratively working for investing this kind of energy efficient equipment. Otherwise, it is not happen. As a management principle, the least cost purchase which supplier was given, the purchase department give the order to the company. This is the normally happen. So it should not happen in the energy efficiency project, so that the maintenance and the energy department as well as the purchase department to be collaboratively working for achieving this kind of energy efficiency. Otherwise, it is not happen. So normally you are also instructing your purchase department always procuring the energy efficient equipment like IE3 or IE4 motor, and the star labeled fans and the appliances for even some domestic applications also, our home also. So whenever you are purchasing, no, some star labeled equipments or appliances are getting, no, you are also getting some savings, because the lifetiming cost, the energy cost is the major element. So every 10 degree increasing in the electric motor, no, its operating temperature, it is over for every 10 degree increasing in motor operating temperature, it leads the life of the motor to be reduced to half. So the motor temperature is also maintained. Otherwise, it is a good indicator. Nowadays, everyone is having a thermal imager or thermal COVID time. We are using the thermal IR meter, no, IR infrared thermometer. Even the thermometer itself, you can see the hot spots with the equipments. So every 10 degree, it leads the life will be half. So it should be maintained, the temperature should be optimum. And rewinding is not done properly, the efficiency can be reduced by 5 to 8%. And variable speed drive can be, VFD can be adapted wherever it is possible. So you can save almost 5 to 15%. One example, classical example is for the air compressor. Wherever the air compressor loading is less than 60% or 70% loading is there, you may go with the VFD, so that the unloading power 30% energy can be saved. At least 20% of the unloading cost can be saved. So the payback is also very attractive only for the VFDs also. So how the energy efficient motor was manufactured? It uses lost silicon steel inside the this one rotor, and longer core, thicker wires, thinner laminations, and smaller air gap between stator and rotor. Improved winding and lamination designs to minimize the energy consumption. So all these considerations was considered by the OEM to manufacturing the energy efficient motor. So the motor efficiency is generally output power by input power. Everyone knows. So this energy efficiency opportunities in the motors is use energy efficient motors, reduce under voltage, and the power factor correction by capacitor. Mostly about 10 HP motor, you may consider the load and compensation capacitance, so that the capacitance should be parallelly added with the motor. Once the moment the contactor is on, no, the power factor capacitor should be added with the thing, so that your power factor is also corrected in the field itself. And the rewinding is also considered. So more than three times rewinding, it should not permitted within the industry, so that pakka logbook and history book to be maintained for each and every equipment. Then only we can finding how many times it was rewinded. Okay, without data, without history logbook, we can not able to find out this thing rewinding history. And improve the voltage unbalance and the speed control of induction motor by adapting the variable speed drive or variable frequency drive, and optimize the transmission efficiency. In the final slide, I put one example here, and improve the maintenance activities. So this is one of the case study in energy efficient motor. See, consider this is one application for the pump application. So one motor with the energy efficiency is 90% efficient motor is connected. So the pump efficiency is 55. So the record process record is delivered kilowatt is 23.37. Whereas pump efficiency is 55 and the motor efficiency is 90. At this time, the input power is 47.2 kilowatt is drawn from the grid, from the mains. Okay, the same motor was replaced with the energy efficient motor from 90% to 95%. What happened? The same deliver output is same 23.37 kilowatt, same pump efficiency 55%. Only the motor efficiency is changed from 90 to 95%, so that the input power drawn is reduced from 47.2 to 44.7. So suppose this pump is running, for example, coil cooling motor in the furnace. If it is running for the furnace continuously, means 24 hours this pump to be running. So kindly go put a better energy efficient motor here. You can save some here. The one example 47.2 to 44.7. Okay, this is the impact of the efficiency increasing by the motor. And the final is best operating practices in pumps and blowers. See the pumps. As per the well design, the input energy given is 100%. Finally, it was output is 49% only. The useful energy was transmitted into the fluid power. That is a water power. Okay. Whereas in actual case, many cases, this value will be 15 to 25% only. So this much potential is there compared to motor. For pump applications, no, there are a lot of energy can be saved. If the pump was properly designed and properly operated, means we can save a lot of energy. Here, the input power 100% is given in the well design. No, the motor efficiency is 90%, means 10% is losses in motor. Again, pump efficiency 13.5% is losses, and again heat loss in the valve and other losses due to leakages and the flow. And this one head is not proper. all this thing, only effective output is only 49%. But in practically what happened, head loss and valve loss is more in industry, 50%, and more water leakages is there. Gasket is leakage. So proper static head is not maintained, so that your head level is will be reduced and the flow rate is also reduced. All this factor will affecting the performance of the pump, and it needs more energy, and your performance is only 15 to 20%. So this pump example, one of the leading foundry in Coimbatore, we are replacing the coil cooling pump with energy efficient grand force pump. The old pump was 25 HP. The new pump was grand force make 20 HP. From 25 HP to 20 HP, we are changed the energy efficient motor IE3. The nameplate itself, it shows IE3. So the existing pump capacity is 25 and the present is 20 HP. Motor efficiency is 90, here 91.9 IE3 standard. See, another thing is pump efficiency is 68, old one. New one is 76.6. The average energy consumption per hour is 16.2 units to the old one. New one is 11.6, almost 4.8 units can be saved in hour. So this pump is running for continuously for 24 hours. This reading is power analyzer reading was taken on 9th 2019 in the project time I will taken in the company. So 1 hour the old pump was consuming 16.2 units. The new pump, the grand force pump, is taking only 11.57 units only. What is the impact? So almost 4.8 to 5 units can be saved in the new energy efficient pump. So the annual saving at the rate of 7,200 hours is nearly 33,120 units is saved. Cost saving is 2.48 lakhs in a year, and investment cost is 1.1 lakhs. The payback period is only 5.3. During this period, the energy cost is, the average energy cost is around 7 rupees 30 paise something. Now the energy cost is nearly 8.8 rupees per unit. So still this payback is less. Now it is implemented in the recent period, means the payback is less. This is the impact. So any payback is less than a year or 2 year period, it is more attractive with the management. As a maintenance team, as an energy team, as a middle level management, as our role to be convinced to the management, the energy efficiency project to be implemented, and we have to bridge between the supplier as well as this management. We have to adapting the best operating practices as well as the best energy efficiency product in the industries. So again, this is the one example, the productivity restoration through the belt and the pulley. So normally this belt and the pulleys are very, very ignored area in any industry, but we can able to some savings can be achieved through this thing. See, this is one of the dust collection system used in the sand, this one, no, dust collector, sand plant, salt blast dust collection system. This blower capacity is 20 HP. Okay, the blower motor capacity is 20 HP. During our visit, we had see the more slippage is more due to this more cut in the belt, so that the motor output, the mechanical efficiency is not properly transmitted from this motor to the blower driven by using this old one. Okay, because of this old one, and the pulleys are worn out, and also the belt is also cutting in the lot of edges, so that it was more wobbled. Okay, the slippage is high. So by correcting this, no, we can do by with the help of one of the OEM in Coimbatore. So he is a very pioneer in the belt and pulley replacement and the productivity restoration. So once analyzing, they suggested to replacing the existing motor driven pulley and blower driven pulley with the cogged belt. The earlier one is a flat belt pulley, flat belt. Now it is replaced with the cogged belt. That's called as a timing model. And see the tension before it goes up to 3 inches and 4 inches, one belt to another belt. Now it is only 10 mm or 12 mm. This is the tightness is required for effective transmission, mechanical transmission from the motor pulley to the driven pulley. So by adapting this pulley change and the belt pulley, now belt and the pulley changes in this thing, so the consumption was reduced to 5.33. This is for the earlier photographs is shown for the short blasting dust collection. This value is shown for the short blast machine impeller. Okay, in the impeller is also the same thing, more cut in the belt, and there is a no efficiency is not transferred properly. Because of this, the batch timing is increased to 8 minutes from the 5 minutes. Actually, the OEM refer only 5 minutes per batch, but due to this mechanical inefficiency, the efficiency not transfer. The company was increasing slowly from 5 minutes to 8 minutes. So average energy consumption per batch is 5.33. By adapting the new energy efficient belt with the proper pulley size to reduce the slippages, your mechanical efficiency is increasing, so that your batch timing will be reduced to 5 minutes from again bring down to the 5 minutes. Now the energy consumption per batch is 3.33. Almost 2 units can be saved. So timing is also 3 minutes saved. So in a day we can take extra 10 batches per day, and also your energy savings also. Existing operation they are using only 20 batches per day. Now also 20 batches per day, because that much castings will be loaded to the sort flash machine. So directly 20 batches into 2 units means 40 units can be saved in a day. In a day 40 units means 40 into 6 days into 4 weeks into 12 weeks. The payback is very, very attractive. So the average investment cost per impeller is almost somewhere 12,000 to 13,000 rupees only. So the payback period is also very less than 4 months. The achievement was done. So here 40. So yearly saving at the rate of 300 days, 12,000 units can be saved. And cost saving is 0.96, and the total investment cost is 0.4 lakhs, because it is considered for the pulley and the belt also. So the payback period is only 5 months. Okay, thank you. So during the next session, we can detailedly discuss about the energy efficiency measure in air compressor, and what is the importance of energy audit in the next session. Hello.
Yeah, yes, sir. Yes, sir. It is a very good presentation. Yeah. Now it is open to the forum. The members can raise their questions. Is there any questions? Sir, I will ask my own question.
Yeah.
Now, in our foundry, we have, you told us that we need to operate in high kilowatt, maximum kilowatt.
Yes.
So because of the low voltage in the line, we are unable to meet the maximum kilowatt sometimes, not regularly, but night it is okay, but during daytime, because of the low voltage.
Incoming voltage is low.
Input voltage is low. We are unable to offset in the transformer. So we have kept the maximum tap.
Okay.
So even then we are unable to keep it at the maximum kilowatt. So is there any mechanism to raise the voltage to the maximum level?
For the furnace transformer itself.
For the furnace, furnace voltage we are getting low, but transformer the maximum tapping is done. So beyond that there is no limit.
But your issue is during the daytime the voltage is low.
Low voltage,
but
yes,
the same thing is reversed in the night timing voltage is high. Correct.
Yeah, correct.
In night timing voltage
is okay, but daytime sometime not regularly. Sometime we are having the issue of low voltage, so the output is coming low.
See, normally for the auxiliary loads, for 433 voltage, they are having a solution with the OLTC, on-load tap changer. But whereas for the furnace applications, even though some small capacity to higher capacity, the OLTC is not placed in any furnaces, because the furnace voltage, secondary voltage is different, 575 voltage.
Yes, sir.
Yeah. So it is some difficulties, sir. So it is some areas these problems are faced, because more industrial area or the substation is not handling that much capacity, the voltage drop will be there. Okay, so that you may give the request as a forum. So how many units are there in your area? Like a cluster means you may give a request to the TNEB and give a letter to EB. So we are facing a lot of voltage problem issues. Kindly rectify, because they have to rectify the problem.
Okay. So I thought, is there any
auxiliary load means definitely we do. Okay.
So any booster mechanism is there like that? I was thinking.
For the compressor, for the transformer, this one. No, sir. I don't know. So far, the booster thing is not there. Only solution is OLTC is the solution. But for furnace transformer, the OLTC is not placed in anywhere. Okay.
So you have also told that the induction furnaces are now operating with IGBT and all, and you said it is getting around 600 kilowatt. But nowadays with the IGBT and all, people are meeting around 550 kilowatt. That is what I heard,
Yes,
and
sir.
I saw the latest furnaces. 550
Yes,
kilowatt is the normal now.
Okay. Yeah, IGBT gives the OEM itself, they are also declared by adapting the normal thyristor switching to IGBT means 10 to 15% energy saving can be achieved.
Yes, sir.
Okay, recently, last week, I do one baseline audit in one of the steel industry in Erode area. So they are adapting a brand new 24 pulse IGBT rectifier. 10 ton is the crucible capacity. The furnace power capacity is almost 4,000 kilowatt. Okay, they are having Pakka setup with poking mechanism and other thing. They take only 620 units because they put very low grade steel waste only. All are this one scrap based only they are using. The sponge iron is used for only 10 to 15% only. Okay, even though but that raw material they achieve 620. As per the commissioning report by the OEM, no furnace manufacturer, they take almost 570 to 580 units per ton only in the trial run itself.
Right.
So IGBT furnaces will give more this one, sir, energy efficient. Also, the 24 pulse conversion, no, it reduces the harmonics very low level because normally foundries are having 6 pulse rectifiers. It leads more than 20% harmonics in the point of common coupling EB. By changing from 12 pulse, nowadays the concept says 24 pulse. So I measured in the EB mains itself for almost 6 hours in the steel industry. The current harmonics and voltage harmonics is almost same. Current harmonics is voltage harmonics is 2.5%. Current harmonics is also 2.6 or 2.7 only. Because as per the CE norms, 8% to be maintained. Above 8% means penalty is there. So IGBT based furnaces will give more energy savings. Sir.
Yes, sir. Thank you, sir. Thank you.
Okay, sir. Sir, any other questions, sir?
Okay, sir. So if there is no questions, then we will go for vote of thanks, sir.
Okay, sir. Okay.
Okay, sir. Happy afternoon, gentlemen. We had a very good webinar on energy efficiency, and it gives me immense pleasure to propose vote of thanks at the end of the program, training seminar. So, on behalf of IAF Chennai chapter, I extend my sincere thanks with gratitude to Dr. Sivakumar. So he explained in detail where all the areas we can save energy, either energy conservation or energy efficiency. Both the way he talked about the details. And nowadays he said the Indian government is also tightening the belt, and those who are in export market, they are talking about the carbon footprint. So 1 ton of casting, how much CO2 we are consuming, like that they are asking. So if we don't meet all these CO2 emissions norms, there will be extra cost we have to pay. So the viability of the export market will become very tough. So definitely the techniques are very much useful, and we have to use the measures to reduce the energy consumption per ton of liquid metal or the per ton of good castings. So the techniques are very much, sir. Thank you so much for your valuable inputs, and definitely we people will keep in touch with you, and we appreciate your time. Thank you so much, sir.
Thank you, sir. Thank you.
Yeah, yes, sir. Then I thank our Chennai chapter members and the members from other chapters, regions. So all the members, once again, I thank you one and all. Thank you, sir. Thank you so much.
Thank you, sir. Thank you.